This is the first in a series of videos focused on providing a little bit of background in global positioning systems. So first of all, we've got to talk a little bit about some of the nomenclature used. A lot of these terms you'll hear kind of interchanged a lot. GPS is a term, global positioning system, that we hear used a lot. Typically, it's the term that we use to refer to the U.S. Satellite constellation, which is known as the Navstar program. But nowadays, we typically use GPS really to represent any type of global positioning system. The actual term for that we should be using is Global Navigation Satellite System, or GNSS, and you'll see this in a lot of technical material, and sometimes you'll see this in receivers. Basically, it just refers to a generic term for a group of satellites that work together to provide kind of global coverage on the Earth as far as positioning goes. Really, it's kind of a difference between calling something a Kleenex brand name and a facial tissue. So a generic term versus a specific term. So that's just a kind of a little bit of background here. Whenever I see that or you hear that, sometimes you're going to hear both terms being interchanged. But there are a lot of other systems out there now. Originally, the U.S. constellation was the first and original system out there, but there are currently quite a few systems out there. The Russian GLONASS system, the Galileo systems coming online for the European Union, and as well as the Chinese regional system, Compass, which is now the Beidou system, which is now becoming a worldwide navigation system. The Indian constellations focus mainly on the Asian continent, as well as the Quasi-Zenith system, which is the Japanese regional system to help with navigation there and provide some augmentation in areas where we have issues in that part of the world. So those two are not necessarily a global system. The ones on the left-hand side, the three there, are global systems that are either currently in action, like the Russian system, or that are currently being upgraded, like the Beidou and the Galileo systems. If we look at the U.S. system, the Navstar program, which was what kind of initiated this whole process, started in about 73, roughly, and then by 78, the first satellite was launched. And by 89, we had the first block of satellites that were operational. So we name satellites based off of their kind of series, and we call them blocks, Block 1, Block 2. So the first kind of satellites in the program were Block 1s, and then Block 2 was when they started launching the kind of operational ones. Now, this took a lot of years of research and a lot of dollars of research. About $12 billion worth of research went into to get this kind of program off the ground. And even currently, we tend to spend quite a bit of money in the U.S. just to maintain the system. Just for the current upcoming fiscal year, as I'm recording this, we're going to be spending about almost $1.2 billion that's coming in to help maintain this system and maintain satellites and maintain the whole control system. It's currently being managed by the U.S. Air Force for the Department of Defense. The last satellite was launched for the current constellation. It's positioned in 93, and they did some testing through the end of June, and by the first part of July of 95, it became fully operational for use commercially in other areas. The way that system works is basically each of the satellites provide a coded signal, and we'll get deeper into this as we move forward. And we basically compute the distance or the time lapse between the point at which the satellite basically sent the signal to the time at which our receiver receives that signal. So that gives us a distance, because we can calculate the distance based off of the velocity of radio waves, which is the speed of light, roughly, and the time lapse between those 2 points. And so having 3 dimensions allows us to trilaterate a position, and we typically like to have at least 4 satellites really to be able to make the math work out, because typically our receivers aren't going to have the same type of precision clock that our normal satellites are going to have, of course. And so having that fourth one provides a time kind of offset to allow us to improve the accuracy of our receiver clock. And so as we add more and more satellites, because really we'd only need 4 to get an exact position if everything was perfect, but there's going to be error inherent with the system. And so having more satellites locked and measuring those distances is going to allow us to increase that accuracy as we try to calculate our position. And there's really kind of 3 parts that the whole satellite system is composed of. The first part we've been talking about, which is the space segment. We're going to move forward and talk about that in the next video or two. The second part is the control segment, which actually monitors and helps to control and move those satellites in the correct orbit path. And then the last piece is the end user segment. And that's what we're going to really get into when we start talking about more of how we utilize that data to provide position of ourselves wherever we are on the globe.